So my name is Chris Thalinger. I work for Twitter, obviously, because I have the Twitter shirt and no one else in here does. So I'm the guy. And I live in Hawaii, by the way. But don't worry, I live on Oahu. All the lava is on the Big Island, so it's all good. First question, most important question of the day. Who has a Twitter account in here? Ooh, that's not even half. Very disappointing. So everyone who has a Twitter account, I would encourage you to tweet about this talk, take a picture, add this hashtag. Twitter has a VM team, and it's a VM team of 4 people. We have 3 GC engineers, and they're 24/7 busy fixing GC issues and making our microservices run better. And then there's me, I'm the compiler guy, and I'm just touring from one conference to the other and do nothing, pretty much. So I hope this is not recorded. So if you tweet about it, add that hashtag so that my other team colleagues know that I was here and did a great job. Everyone who does not have a Twitter account, you create one right now and do the same thing. Good. So why this talk? The other talk that I was suggesting to you, but you didn't like it. I basically show how much money we're saving at Twitter by using Graal. And the reason I'm giving this talk is because I want Graal to be used more. And so one of the things why I'm trying to tell you this is you could potentially save money as well as we are doing. And it's a lot of money, really, it is. But I also want Graal to become a more mature compiler. So that means I want to fix bugs, and I want to improve Graal, because the more code we have running on Graal, the more bugs we'll find, right? So this is one of the reasons why I'm giving my talks. Then, especially after the other talk, people come up to me and ask me, so is it safe to use? Which is a reasonable question, because it's still an experimental JIT compiler, right? But I can tell you, we're using Graal in production for many, many months now. And our data centers are still fine, they are not on fire, so it's good. Yes, it's safe to use. Then a lot of people ask me, how do I use it, and where do I get it? And exactly these 2 questions we're going to answer today. And then sometimes when people actually use it, I get emails and they are mostly complaining about benchmark numbers, so they're just taking their favorite benchmark they were using throughout their whole life, SpecGBB or SpecJVM98, best benchmark ever. And then they say, well, Graal actually sucks. And the main reason for this is because they don't understand, or they don't know, that Graal has very, very different properties than, for example, C2 has. One of the biggest differences is C2 is written in C++ and Graal is written in Java, and we are going to talk about this a lot. So if you want to know more about the money-saving part, that's the talk you didn't want to hear. So watch it on YouTube. There are a bunch of versions of this talk. So what is Graal? I think most people now know what Graal is. Now I probably should add, because there was this Graal VM announcement, right? And most people saw that one. I'm not talking about Graal VM. I'm not affiliated with Oracle Labs. I never worked for Oracle Labs, in Oracle Labs. I was working on Graal, the compiler, which is very different than what Graal VM is. Graal VM contains Graal, the compiler, and a bunch of other things like Substrate VM and Truffle and you name it, all these things. But today I'm only talking about the JIT compiler. Okay, so Graal is a Java virtual machine just-in-time compiler. Who knows what a just-in-time compiler is? Yeah, it's pretty good. So in a nutshell, it takes Java bytecode during runtime, during the execution of your application, takes Java bytecode and translates it into native code so that your application is running faster. That's what it's doing. Graal is actively developed by Oracle Labs. You know that because of the Graal VM announcement, so there's a lot of hype going on right now. There's an official OpenJDK project, this URL. Then the source code lives on GitHub, and it uses JVM CI, which is JEP 243 that we included in JDK 9. So since JDK 9, you can download an official Oracle OpenJDK build, and you can run with Graal if you want to. And then lastly, as I said, Graal is written in Java. So this is the most important part that you have to understand, because Java has very different properties than C++ does. And we are going to talk about this a lot. So remember during the talk that this is written in Java, Graal. So first one, where do I get it? So in JDK 9, we added CHEP 295 ahead of time compilation. And ahead of time compilation in the JDK, which is very different to what Graal VM does, by the way. We are using Graal as the code generating backend. So it's pretty much the AOT solution in JDK 9 is a Java program that reads in your Java classes, your jar file, whatever, and it spits out a shared library, a .so, in a way, right? And then you can use that. So since JDK 9, you can technically use it, but it got simpler because CHEP 317 was introduced in JDK 10 and actually delivered in JDK 10. And it's Oracle's way of saying, okay, yeah, we are kind of trying to support this thing, so please give it a shot. So it's now officially, yeah, supported in JDK 10 more or less. So this makes it much, much easier for me to do this talk and this demo. I understand that most of you are not running JDK 10 in production because even we at Twitter don't. We are still on Java 8. But, you know, there are other ways to get there. So I'm part of the Oracle Developers Champions program, by the way. So through that program, they give me free cloud credits to use their cloud. And so this is what we're going to do here in this demo. Here we go, cloud. So as I said at the very beginning, the talk is I do everything from scratch. So it's a little risky that I do this, especially things can go wrong, can change. Wi-Fi might be flaky, and I can't do stuff anymore. But every time I see a talk where people do demos, I sit there and I wonder how many hours did they spend that this demo will run fine, most likely on their laptop, right? So I decided I don't do this. I fire up a completely empty cloud instance right now in front of your eyes. It has nothing installed. It doesn't even have Java. And so everything I do today is pretty much what you have to do to run with Graal as well. This has pros and cons. One of the cons is we have to wait for stuff to download and initialize and stuff like this. So there will be a lot of awkward pauses during this talk, and they will be really awkward. So let's do this. Okay, let's log in here. I hope they haven't changed the UI. Once they changed the UI and I initialized the wrong instance, that was embarrassing. So let's see, we want a cloud instance, a compute instance, and we do it in Frankfurt. Yes, that's the closest. Okay, here we go. So we say GeeCON up here, then we do it in here. Oh, that's a newer version. I always used 7.4, so I do it now as well because I'm not sure what's going to happen if I use the other one. We're using this VM one because it has 4 cores. It's for Java, it likes to have more cores, so we use that. Then we need an SSH key here. So here we go, edit. And this is not important, and then create. And then I hope it's, oh no. Well, I told you. Let's see. What if I put it in another one? Damn it. What if I kill this guy? Well, yeah, that's the risky part, right? Okay, instances. Let's try again. Let's try another domain, because I think they limit the version, the number of VM, especially this dense IO one. They limit it to 1. Why is it not? Oh, here. Yes, let's try this one. Much better. That was close. The backup solution would have been I can do everything on my laptop as well. But it's much more fun in the cloud because then, All right, so this one's provisioning now. I don't know. I'm really not using cloud stuff usually because Twitter, we have our own data centers, our own machines. We don't use the cloud yet. because, you know, we're going to use Google Cloud soon, at least for some of our stuff. So this is provisioning now. It should be done pretty soon, I think. So we're looking for this public IP address here. And then here. This is not going to work because it's not up yet. And we have to wait for this. I'm not exactly sure how long it takes. It takes at least 2 or 3 minutes for the thing to provision, and then to, you know, image it, and then to boot up your Linux container, and so on and so on. So in the meantime, we're going back here, and I'm telling you a little bit about myself. So as I said, my name is Chris. I work on JVMs for over 13 or 14 years now, I think. All the time, pretty much on compilers. So I do a lot of compiler work, so I'd like to call out people. And so who can remember GNU GlassPath back in the day? Old people, yes, old people, 2 old people, very good. That was fun. So back in the day, we were all doing free Java. Charlie has a talk about free Java. I think it's later today. Yeah, right after this. So he's talking about all this history stuff, where we all met up at FOSDEM. We're drinking beer for fun, Wild West. Oracle, Sun were the bad guys back then. But then suddenly they open sourced everything, right? And we became friends, and we let them drink beer with us and buy it. Especially that was the important part. They bought beer, they still do today. And then after a while, so I was working on this other JVM implementation using GNU GlassPath, and then I started to work for some microsystems. And I was part of the Hotspot compiler team all the time, mostly working on C2. A little bit of C1 as well. And then Oracle acquired Sun. You know, what can you say about that? The biggest project I was working on during my time at Sun Oracle was, I guess, JSR 292, which is invoke dynamic support in the JVM. So John Rose and I wrote that thing a bunch of years ago now. And it was a lot of work. I did all of the compiler support to make that happen, a little bit of interpreter support, and then we had a second implementation of JSR 292, which uses Lambda forms. I don't know if you heard this before. We moved a lot of the logic that was in the VM before in C++ code over into the core library, into Java land. So I wrote a lot of that implementation too. Technically, if it doesn't work, you could blame me, but you know, a lot of people after me worked on it and fixed issues and added code, so I think they introduced the bugs. My code was perfectly fine. Then, as I mentioned already earlier, JDK 9, JEP 243, the Java level JVM compiler interface. We basically took the interface that Oracle Labs was developing for Graal and stripped it out of Graal and put it into OpenJDK. That's really all we did. We kind of polished it up a little bit, but since JDK 9, you can just download a Graal version from, let's say, GitHub, build it yourself, and then you plug it in, and it just runs. So that was always the plan, to do it this way. And for JEP 295, for ahead of time compilation, we're exactly doing this, right? There's a version of Graal in JDK 9 and 10, and will be in 11 and so on, as a Java module, right? It's just a Java module that has all the Graal code in it, and we'll see that later. I'll show you where it is. Right, and I work for the Twitter VM team now, which is great. Love Twitter, great company. And what else? I run a conference called Lava One. Who's been there? Excellent, 2 people. Love these people. So I don't know how the weather is in January here, but we were surfing and running around in board shorts all the time. So I'm just saying, if you want to, I'm doing it next year again in January. So mark your calendars. Here we go. So let's see if that thing hopefully came up. It doesn't look like it, to be honest. Doesn't look like it. That doesn't make me happy. Yeah, that's not good. You should have picked the other talk. That was really the wrong one. I was worried because this provisioning thing that usually goes away after 5-6 seconds. Let me try it again, and if it doesn't work, then we have to run all of it on my laptop. which is fine now because with JDK 10 and 9, Graal is only in JDK 9 when you run on Linux, but since 10, there's support for all the operating systems, so you can also do it on the Mac. Yeah, this is not working at all. You know what? Let me try US. Let's do that. Well, let's do this. Let's call this GeeCON. And we do it here, and we use that. And we say the Dense.io guy, the keys, and here we go. Let's see if that works. The problem now is I told you everything about me, so now we have to wait for this instance to come if it's really coming up. So we have an IP address, that's good. If that provisioning turns green and it says running, then we are almost good. Then we just have to wait for the thing to come up. These are the awkward pauses I talked about earlier, you remember? I don't think it's coming. Oh man, Oracle. I'm glad this is not an Oracle event. That will be tomorrow. So I have to talk to a bunch of people because otherwise I can't do this thing tomorrow. I don't think it's coming. Doesn't look like it. They sometimes send me email. I shouldn't say this, but again, it's not an Oracle event. So they sometimes send me emails the day before I have a talk. Oh, we're doing system management tomorrow, and your things will be. Well, there you go. Well, maybe it's coming up. Okay. We'll see. It's only a matter of time. So what else can I tell you in the meantime? Can I skip a bunch of things here? Probably not. No, it's all. I have to download it and then I have to show you. So who's coming to level 1 then? Ah, very good. Yeah, there's one guy. He has already the flight tickets. So we're probably doing second week or something of January. And because I think it's not colliding with anything else. And this time we do it in Honolulu, in Waikiki this year, right? It was this year. We did it in a small town called Laia on the North Shore. That was nice, but it's a far drive, especially for local people. So that's why we decided we do it in Honolulu, where all the IT industry basically is. Yeah, it would be great if you could come. I can't talk about Lava 1 for 3 minutes, I think, but what else can I tell you in the meantime? Connection refused. Yeah, that will take a little bit. Did you switch to the other presentation? Well, technically I could. Yes, you're right. But so I could do this. Wait. Yeah, I'll just do this real quick. I blast through them. So this is the reason why you should be using Graal. So this is the tweet service that's reading and writing tweets, and it's basically written entirely in Scala. Like 92% of this code are written in Scala. And so I did this experiment. I had dedicated machines so that the benchmark numbers were actually pretty stable. And so this is the setup we used. All the instances received the exact same number of requests. And so this is just showing that we're actually receiving the same number of requests. I'm testing C2 Graal and C2 and Graal on JDK 9 as well, just to see if there's a difference. The main, let's talk about this one as well. So one thing that Graal has is it has a better escape analysis implementation than C2 has. C2 has the traditional escape analysis, and then Graal has something called partial escape analysis, and it's slightly better. And what we would like to see is, there's no y-axis. That's on purpose because that's confidential information and I can tell you, but you'll see percentage numbers, so you'll know. So Graal is using less GC cycles to run the same or to serve the same number of requests for tweets. And yeah, this is for JDK 9, not that important. And it's about 2.5% less GC cycles you have to do. That's already a win. It's not a lot, but it's a good win. And then I'm not talking about old gen, that's not important. This is the important one. So we want to reduce the user CPU time to serve the same number of requests. So this should be lower, hopefully, and it is. And then this is slightly different, and I think it's slightly different because of inlining decisions that C2 has made. This is 9 again. And I put it in a ratio so that we can see how much it really is. And it's 11%. This is a lot, you know, especially the tweet service. We have thousands of instances of the tweet service, and it's only one out of hundreds of service microservices we have. So for our data center, if we can save 11% of CPU, that means we can reduce the pool for that particular microservice, how many instances it has, because we can technically serve more with one instance, like 11% more technically. Yeah, that's why you should be trying it. I'm not saying you should be using it, but you should at least give it a try, and maybe it works for you as well as it does for us. So let's see here. Yeah, much better. Okay, cool. Can you read that? Yeah? No? Okay, one thing we need, the most important thing we need, is we need JDK 10. Here we go, and we download it for Linux. So this is where you get it, right? You go to jdk.java.net. It's like on the previous one of my previous slides here. You go there, you download it. One thing we have to do. Oh yeah, I told you there's no Java installed, right? There's nothing on this cloud instance. And one thing we have to do is yum install git, because we need this. So there's literally nothing in this cloud instance installed. So everything, we have to do everything from scratch. And yeah, this is pretty okay. Only takes 30 seconds to get it. Good. Let's wait for this. And then I'll show you the Java module I was talking about that you need, or that you should have to actually be able to turn on Graal. A little bit more, 4 seconds to. Excellent, okay. So the other thing about talks like this is if you type in front of a lot of people, you know, there might be a lot of typos. We'll see how it is today. Usually I'm pretty good, but that doesn't mean anything. I also say the cloud instance comes up. So we set Java home because we are going to use it many, many times. And we are going to put Java on the path as well because we're using it all the time. Here we go. So we have JDK 10 now. Going to install Git over here. And there's since 9 you have a feature. No, let me do something else first, otherwise I'll forget. So we are going to set Java tool options. It's basically an environment variable that the Java launcher picks up, and we're doing this because we are by default using parallel GC for our experiments here, because we're going to look at GC output a little later, and looking at parallel output is so much easier than G1. There's a typo. Oh yeah, very good, thank you so much. As I said, it's the typing. Right, and also we don't want the heuristics that G1 is doing. We just want a plain GC that just works. So parallel is pretty good for this. And we are also using a very small heap size, maximum heap size and start heap size of like 512 megabytes, and that's enough. And I'm doing this, especially I'm setting the same as maximum and start for. Again, C2 is written in C++ and Graal is written in Java. So when Graal is doing its job, it's like the heap expansion would be different than the one with C2, and we want to compare more or less apples to apples, and so that's why we're doing this. Okay, so we copy that over here. We do the same thing here. We set Java home, and we set the path. Here we go. And then this, and then we need something additional here. And we're going to chap 243. And when you scroll all the way down, it will tell you how to enable Graal, or how to enable a JVMCI compiler, because JVMCI is technically not, you could plug in any compiler that's written in Java, let's put it this way. Today there's only one, and that's Graal, okay, so, but technically you could plug anyone in. So JVM-CI itself is still an experimental VM option, so we have to turn that on. And then this only enables JVM-CI, so you're then allowed to access the API, but it does not turn on Graal or the JVM-CI compiler. You have to use this guy here. You tell JVM-CI, okay, use the JVM-CI compiler, and then technically you could name or give it the name of the compiler, but since there's only one, it's picking up that one automatically. So we're using these, put them in here as well, and then when you do that, you'll see, okay, it's picking it up, and then just printing the version. Okay, that's all. So since the module system is out, there's an option called list modules. Typing list modules, and I think it's like 75 modules that the JDK has today. And we want to look for some modules that are called jdk.internal.vm something, and there are 3. And the one, the jdk.internal.vm.ci is JVM-CI. So that module contains the JVM-CI source code, at least the Java part of it. Of course, there's a big C++ part in the VM as well, with all the native methods that give out all the information. And then the jdk.internal.vm.compiler, that's just a module that contains the Graal source code. So if you have these 2 modules in your JDK, you're good to go. You can just turn it on, and then we'll automatically switch out C2 with Graal. Okay, here we go. Let's go back here. This guy. So how do I use it? Well, you get a JDK with Graal with that module, and we verified we have that, so check. And then the only thing you have to do is you have to turn it on, right? So let me go to a demo and show you how to use it. And I also have to download something else. We download the Scala da capo benchmark. We're going to use it for a bunch of things. And I think that server is somewhere in Europe. Oh no, it's not. Oh, it's actually pretty fast. Yeah, that's the problem I have. It's 260 megabytes, and then it downloads with 1 megabyte per second. It's ridiculous. We have to wait forever. So okay, good. So as you saw, we put all these flags in our environment variable, so it's picking it up automatically. So everything we have to do now is just run it, and it turns it on automatically. So this, oh yeah, there's an option that I want to enable. Hang on. So when we do print flags final, and we grab for, I gotta do a version here, otherwise there's too much output. We want to grab for something for all the JVM-CI command line flags, and so there's a handful, like 10 or so, and you see we have enabled it, right? We have enabled JVM-CI. This is true, so we have enabled the JVM-CI compiler, so that means, okay, Graal is now being used. So the one thing that I'm looking for is here, JVM-CI print properties. And it goes like this. And it's a very long list of properties, right? So I don't even know how many, but you see it's a very long list of stuff. There's a short section up here that's JVM-CI properties, and the rest is all Graal. So everything you can tune Graal, all the command line -xx version, -xx flags for I don't know, setting things for C1 and C2. That's basically all Java properties, -D, because Graal is written in Java, so we decided it would be easier to do it through Java properties. And for JVM-CI, there are a few that you can set as well, and we're looking for this one. That's called init timer. And if I do this, and I say -D init timer, and you say equals true because it's a Java property, so there should be output that tells us that JVM-CI is being initialized and Graal is being initialized, but there's no output. So did we do anything wrong? No, we didn't, because JVM-CI and Graal are being lazily initialized. So if we're looking at the compilations that are happening when we do a dash version, these are all the methods that are being compiled. And do people know what tiered compilation is? Okay, a handful. So tiered compilation, you know what hotspot is? Yes, the JVM of OpenJDK. So hotspot has 2 JIT compilers, one called C1 or client compiler, and the other one is called C2 or server compiler. And the way it's set up by default these days is you start out interpreting your Java bytecode and then at some point it will be compiled by C1, and it collects profiling data, and then it uses that profiling data to compile with C2, and you're going through tiers to reach your last tier and your peak performance code, basically. So that's tiered compilation. And the third column tells you the tier level. So 0 is not really showing up, but 0 is technically interpreting. 1, 2, and 3 are different C1 levels, and level 4 would be C2. And there are no tier 4 level compilations because the methods are not getting hot enough to be actually compiled with tier 4. So since there are no tier 4 compilations, there are no compilations scheduled with Graal, and so JVM-CI is not being initialized. So we have to run a little bit more to see that. And so we're using, let's call it a couple benchmark thing in. It has an option called -L. If I run this over here, you see it's just printing out all the benchmarks it has, right? If I run it over here, we can see, oh, yeah, it's printing something. So there's probably something was getting hot enough that we are actually initializing stuff. But as you can see, it's starting to initialize JVM-CI, but it's not finishing it. And the reason is that the execution of the -L exits sooner than the initialization of JVM-CI and Graal is done to actually do a compilation. So it just, the VM exits before it is finished. So what we have to do is we run a small benchmark of Aurora. And you can see, okay, yeah, now it's initializing stuff, right? So it's initializing everything off JVM-CI. It says it's done. It took 74 milliseconds. And then it calls this thing compiler configuration factory, which then selects the JVM-CI compiler. In this case, we only have one, so it automatically picks up Graal. And then you can see it's initializing a class called hotspot Graal runtime, doing a bunch of things, initializing our AMD 64 backend, and so on and so on. And then it runs the benchmark. And it kind of doesn't really finish the initialization. I think the reason why this is happening because the copper benchmark harness is redirecting standard out and standard error to a file at some point, so we are not seeing when it's actually done. Good. If we are running this over here with C2, it looks something like that. It will be actually faster, slightly. So it's 4.4 seconds to 5.2 seconds. So it's roughly 600 milliseconds slower for this one iteration of this very short running benchmark, which is only 5 seconds. And yeah, so I'll leave it at this for now, because if I go back here, if I remember correctly, this is because of bootstrapping. And bootstrapping is very important because Graal is just another Java application running in your JVM, especially when you're running the way I do it, or even the way we run it at Twitter. Because at Twitter, we are still running on Java 8, and Java 8 does not have AOT compilation. So we couldn't technically AOT compile Graal for us, so we're just doing the bootstrap cycle, which is fine. You will see why. So Graal, written in Java, it loads a bunch of Java classes, obviously. It has Java methods because it has to do its job, and it's all written in Java. And these methods at some point need to be compiled as well, because otherwise your compiler throughput would be the worst, right? You couldn't wait that long for your application methods to be ready and to have native code for your application. So let's go to a Bootstrap demo and show you what I'm talking about. You can, I'm not suggesting you're doing this, but sometimes it's a useful flag. You can do an explicit Bootstrap cycle with Graal, and that looks something like this. Okay, here we go. Every dot that it prints are 100 methods compiled. And what this flag does, it takes all the methods of Java lang object, which are only, I think, 5 or so that actually have Java code, and it schedules them for compilation. And they are all very simple. They're only like 2-3 lines long or something. And while it compiles these very simple methods, Graal's code itself, because it's written in Java, gets hot as well. And so it has to compile itself as well. That's what's a bootstrap cycle. It's this meta-circular problem that you have if you write a compiler or whatever feature of your JVM in the same language that your JVM is actually executing. There is this bootstrap issue, that you just have. So we compiled roughly 2,600 methods in about 10 seconds, which is a very long time, right? No one wants to wait for his JVM to start up 10 seconds just to run a simple whatever command line tool. But this is an explicit bootstrap, and that's not the way it's done when you just run it the way I did before. Because if I do this again, let me do this again, right? And take this out. Because this runs in 5.5 or something, and it's only 600 milliseconds slower than the C2 version. And if I do, well, yeah, let me do that. Let me delete this stuff, and let's do 3 iterations of that guy. And here as well. Takes a little bit. Awkward pause. Everyone's waiting for benchmark numbers. Okay, here we go. So the C2 version gets slightly faster, right? Because you're compiling more and more and more through the iterations, and you end up at like 4 seconds. And over there, you start at 5.5, and then you go down to 4.4, which is pretty much the same as C2, and you end up almost at exactly the same time. And so what's happening is, you remember when we initialized our cloud instance, it had 4 cores. So I'm no cloud expert, and I don't know how you run your stuff, but I don't think anyone's running his JVM on a system with just 1 core. That would be stupid, because then all your parallel GC would be only running on 1 CPU. That doesn't really help. So when you start up your application, in this case our small benchmark program, what the VM does, it has a bunch of compiler threads. And what the VM does, it's just taking these unused cores and compiles the methods it needs on the side. And that's why we are not seeing a 10-second difference here than the one when we're doing an explicit bootstrap. So, and after, almost after 5 seconds already, we are at the same execution speed of the benchmark as with C2. So the bootstrapping is really not an issue in most cases. We at Twitter, we are running, I don't know, I would say 20 now. I can't remember the exact number, but maybe 20 of our most important microservices on Graal, and we use it that way. I told you we're running 8, so we can't AOT compile it, so we have to do the bootstrap every time. And we restart some of our microservices multiple times a week. And we're doing this now for 10 months. And we didn't have a single issue with the bootstrap being too slow or something like this. So believe me when I say most of the time this is not important. And if you are lucky and you run on JDK 9 or 10 already in production, you can AOT compile Graal. And then all this goes away, right? It's not an issue anymore. All right, going back. So what we learned here is that bootstrapping compiles a lot of methods. Yes, that's true. I didn't show you the non-tiered one because I only have 10 minutes left. But we compile about 2,500 in tiered. But if we switch off tiered, that means we only have Graal. We would compile even more, because then Graal really compiles itself with itself. And there's no C1 involved anymore. So there's a lot more compilation going on because a lot more methods get hot. You can do this either up front. Don't do that. Don't use the bootstrap JVM CI flag because it's really not useful. Or on demand during runtime. That's what you should do. You should just the JVM take care of this problem. And then there's a flag that I didn't show you. By default, in the tiered compilation mode, when you start your application, Graal methods are only compiled by C1. And the reason for this is because you don't want to compete. Graal is a high throughput compiler. It produces native code very quickly. And what you want is for Graal to have native code as soon as possible so that it can actually compile your application methods. And you don't want to compete you don't want that Graal methods that need to be compiled to compete with the application methods that you need for your stuff to actually run fast. So that's why it's set up that way. And again, that's the way we at Twitter use it. Okay, so we have to talk a little bit about Java heap usage as well, because you remember Graal is exactly. So very, very important. C1, C2, they use memory, obviously, to compile methods, right? You have to build up compiler graphs. They can be pretty big when there's a lot of inlining or loop unrolling. They get bigger and bigger. And that can go That's not a typical use case. The typical use case is in the low megabytes, like 1, 2, 5, 10, 12, 15 megabytes. That's kind of usually the memory requirement, but it can go up into the hundreds of megabytes. It can. So the issue here is C2 just allocates on the native C heap through malloc, but Graal allocates on the Java heap. So it's more visible. And the problem is we at Twitter do the same thing, right? Because it pretty much translates into money, is you tune your heap size to exactly how much you need. Right? You tune it right there, and then maybe a megabyte more just in case if you go over it. But if that's the case, and you're running fully in production, and suddenly a compilation comes in that needs 500 megabytes of memory, you have a problem, right? You will get an out-of-memory error. So compiling application methods will use Java heap memory. The reason why I say application methods is because of that one flag that's true by default, that compile Graal with C1 only. So that's not using Java heap memory, but your application methods will. So let's look at this real quick. Let's do a Java heap demo. And we are using, again, Aurora, but only one iteration. That's enough. Okay, here we go. So we turn on GZ logging. No, actually, no. We're doing 3 iterations. Let's do that. Okay. Here we go. So while we talk about this one, the other one runs. So you can see there's an explicit GC through system.gc. That's the couple benchmark harness. It does that to clean up the heap before it does a benchmark iteration. But you can see, I don't have a pointer, so I'll use my mouse. Aurora is a very compute-intense benchmark, so it doesn't allocate a lot. And you can see it's like after the benchmark, when the harness cleans up again, we only allocated like 40 megs. That's really not a lot for an iteration. And there are no GCs happening during the benchmarks here and here. So really not a lot happening. But over here with Graal, you can see, yes, we're actually allocating and collecting quite a bit while doing the first iteration. And that's because we are compiling benchmark application methods, and it's using Java heap to do this. But when we go further down to the second iteration, we see, okay, yeah, there was one collection, and it had about 140 megabytes allocated already. But once we are at the third one, and we're only like 15 seconds into our run, that's really not a lot of time, we are pretty much done compiling. And so we run with the same performance as C2, and we're not really allocating memory anymore. And the important part here is when you start up your application or your microservice, I can talk about Twitter microservices here because that's exactly what we're seeing is you start them up. They definitely will take more time to start up than 15 seconds. But at the very beginning, you're just bringing up your system. It's not accepting requests yet, right? We start up our system, our microservices, then they have to connect to a bunch of other microservices, build up, network connections and so on and so on. Then most of the time, you have a tiny little bit of a warm-up loop. We do that too for some of our services. And just then, you are ready to go, right? And at that point, you have already compiled everything. So the issue that you're getting a compilation later, and it happens, yes, there are some compilations happening later during your life cycle, but the majority of them happen in the very beginning, when your system's not fully up and running yet to actually be able to serve requests. We never, at Twitter, not a single one that I can remember, had an issue with this, that we got an out-of-memory error because later a compilation came in that used too much memory. Good. Okay. Then, yes, so Graal uses Java heap memory, very important. The worst case that can happen is because there is no heap isolation yet, so all the allocations that Graal does just happen on the Java heap, it can produce an out-of-memory error, and if you're lucky, that out-of-memory error will get delivered to one of your compiler threads, and that would be fine, because the compiler would just catch it and say, oops, okay, I can't finish this compilation, so let's drop that one and move on. But most of the time, it will likely end up in your application, and it brings your application down. So this is an issue, but there are different approaches that we can solve this issue, and people are working on this. I don't think it will be heap isolation. All the signs point in a different direction, but that will be solved at some point. Again, most memory usage is during startup anyway. The most memory usage by Graal is during startup anyway, when your application is not fully up and running yet. And the memory, keep in mind, the memory that's being allocated is allocated anyway. If you have a cloud container that has, let's say, 4 gigabytes of memory, and that's your limit, it doesn't matter where you allocate the memory, it will be allocated anyway, either malloced or on a Java heap. So you're not saving there. Good. I'll skip that one. I would show you how to download Graal from GitHub and then build it. It's pretty simple, but it would take too long. So I'm not doing this one. I also cannot do in 3 minutes this one. But I want to show you the Scala demo. Okay? So this will take... We're going to increase our heap size a tiny little bit, otherwise we have too many collections. We go to 2 gigabytes here in both cases. And then we run with GC logging on, and we just do 2 iterations. That's usually enough. And it's a benchmark called factory. So let me run that here. And same here. 2 gigabytes. 2 gigabytes, perfect, and 2 iterations of factory, okay. So if we go over here, while the benchmark is running, you can read up on the benchmarks, right? There's the factory benchmark, it's written in Scala. It's doing whatever, toolkit for deployable probabilistic modeling to extract topics, use it latent, I don't know. I really don't know what it's doing. But this benchmark is, and this is a presentation, so I'm picking the best one that I have, right? So this benchmark is really kind of an outlier. The improvement that Graal can do for these benchmarks are ridiculous, and we'll see that. That's why I picked it, obviously. Okay, here we go. So it did that, and now we run this over here. So you can see the first iteration, it did a bunch more because it was just, I don't know what it's doing, right? But the benchmark was probably allocating things, or I don't know, initializing stuff. But here we are, so we started at GC 31 and we ended up at 55. That's like 24 GCs roughly, 25 GCs for one benchmark iteration of this guy. So did I do something wrong? No, I did not. No, that's fine. So over here with Graal, oh yeah, and it took, I know what I did wrong. Yes, sorry. I don't want to run small. I want to run the default one. That's what I want. Sorry about that. But I still have 50 seconds left, so that should almost work. So this, we need to do a little bit more to actually see what's going on. One benchmark run with C2, I think, takes about 27 seconds, if I remember correctly. And it should do, on the second iteration, roughly 40 GCs. Yeah, so like 25. Let's wait for this. Last awkward pause, and then I'm gone. I promise. But it's important. And this benchmark kind of shows why we at Twitter see such an improvement, or why are we saving so much. It's like Graal can handle Scala code really, really well. And this is what we're seeing here. Okay, good. So factory, 2 iterations, let's go. So 50 to 87, so that's almost 40, right? Not quite, 38. So it's 38 GC cycles in 25 seconds of runtime, and you see it goes up to like 750 megabytes, and it collects down to 74. So it's kind of growing a little bit, but it's rather stable. And as you can see in the Graal run, on the first iteration, it's already doing much less GCs. And the runtime compared to C2 is much better. So this should be 20 now, right? 30 to 49, so about 20 GCs. So we cut GCs in half. And the runtime, that's what, how much is this? Like 20% more, 25% faster It's 16 seconds versus 25. So this is a lot. And the reason why this is happening is because the way Graal does inlining is just, I don't necessarily want to say better, but it's different than what C2 does. It doesn't have as many limitations, so in that sense it's better. And inlining combined with the partial escape analysis gives us that win. That's where it's coming from. All right, so Scala demo. So the summary of this talk, very simple. Use the flags, really. I'm encouraging you to give it a try. I can't promise that it will be as good as the factory benchmark, probably not. If you're running Scala code, I'll promise you, you'll see some improvement. If you're running Java code, the story is slightly different. I could do another talk about Java code and how that behaves. But with Java code, I'd like to say it's a 50-50 chance that it's faster or not. But I've seen benchmarks where it's faster, substantially faster. I've seen one where it was slower. At Twitter, we have, like most of our microservices are written in Scala. A handful of them are written in Java. And we've tried them, obviously, and none of them actually showed an improvement. But the win is already, for us at least, it was running with the same performance as C2. And if we can get all of our service to just one compiler, that's for us for maintenance and for supportability much, much better. OK, so give this a try. Let me know how it works. Tweet it out. Add the hashtag if you haven't tweeted about this talk yet. And that's it. Thank you very much.